Hello, I'm Jack. I'm from Idaho State University, College of Technology. I teach in the Civil Engineering Technology program. And today what we're going to do is we're going to look at some fine aggregates. Fine aggregates would be things like sand, clay, and silt particles. And what happens when water is involved. So one of the things we're worried about is soil erosion and sedimentation control. I'm making a little bit of dust here, if you can see. That's because it's these really fine particles that get lifted up into suspension in water and travel down from erosion, sedimentation areas, and hopefully not into places like rivers and streams and wetlands. So today what we're going to do is we're going to take some of the soil and we're going to suspend it in water. So we've got about 7 inches of water in here, and we're going to dump some soil in here with my assistant helping out. And then we're going to put a cap on it and shake it around. And what you should hopefully see is some fine particles, which would be silt and clays that are suspended in the water. And we're going to let it sit for a while to show how it settles out with time. And then once we're done with that, we're going to take this settled material and we're going to dump it through what we call a silt fence material to see how it can separate the silts from the water so that only the water passes through and not the silt, which could hurt things like your wetlands and streams and waterways. Alright, so we're taking a funnel and we're going to take the fine material and pour it into the cylinder. And it makes a little bit of a mess, and you can see the dust coming out the top. Those are the fines. Now we're going to put a plug on the top of that and give it a good shake just to make sure all the fines are washed away from the little bit larger pieces of sand. And all right, looks good. So now what you should have is a situation where we've got larger pieces of sand particles that are on the bottom, and the material should be getting a little bit finer as we get towards the top. And it's all cloudy in the top, so that means that we've got fines that are suspended. They call it a clay layer that's suspended in the water itself, and with time it settles out so that you have just a fine layer of clay. And we'll just let it sit for a few minutes. Alright, so this sample's been setting for about 20 minutes, and as you can see, there's layers that have formed. On the bottom, if we look in here a little bit closer, I don't know how the zoom looks, but there's some finer particles, and it gets finer as you go up. And in fact, you can see a little bit of a layer here. And this layer is the material that was suspended in water. It's fine, very fine material. It's clays and silts, and with time it's settled out. Now, that is the layer that we don't want to get into our wetlands, waterways, streams. And we're going to do a little bit of a test here to use what we call silt fence and dump this material right through the silt fence, and hopefully only the water goes through and all the sand and the silt stays behind and doesn't get through. So that's our next step. So perhaps you've seen this type of material on a construction site before. It's called silt fence. And what it's used for is to protect areas outside the construction site from soil erosion and sedimentation. So what they normally do with it, they have wooden stakes that go along the side, and they'll stake it in the ground, plus they'll dig a little bit of a trench where they put several inches of this material right into the ground and then seal it with earth. So then if it ever rains really hard on the construction site and water is flowing down the construction site and it's picking up sedimentation where you've got silts and clays going through it, hopefully it runs into the silt fence, and the silt fence material, it's a woven material that allows water to go through it, but hopefully not the silts and the clays and the sand material. So what we're going to do is we're going to run a little experiment here where we take a piece of the silt fence material, we're going to put it over a bucket, and we're going to dump this material over the top and see what happens. So we're going to take this sample, take the plug out, and remember it's got sand, clays and silts in here, and then water. And I'm going to dump it into the top of the silt fence, and I should dump it a little bit harder here. And I'm not getting all the material out of it. So what I'm going to do is I'm actually going to take this mess right here that's got silts. As you can see, it's a mucky mess. I'm going to dump this and see if this silt fence works for this material. As you can see, some of it is gathered right on the top, and I can hear water falling through it, and there's a lot of muck in here, but now water is slowly filtering down through the silt fence. And hopefully all that's left is sand and silts and clays, and everything going through here should be relatively clear. And I have to move it around a little bit because some of the passageways get plugged up because of the sand. So I'm just looking for places to let the water flow through. And we just want to see what's left on the silt fence. So it takes a little bit of water pressure to get all the water through there. So that means that the passageways through this material are so small that water can hardly get through there. And let's take a look at what's being left behind. All this muddy, silty water that could have otherwise been transported off, say, a construction site into a wetlands area. Should we look inside? It's basically a little muddy looking yet, but if I feel in there, there's no grit, no sands in it, just very, very fine materials that make up the murkiness in the water. All right, so I'm doing a little bit of a revision to our test. Before, when I did it, I didn't have a whole lot of water in there, and I had material on the bottom. So what I did now, because I want to get all this material to go through go onto the silt fence, so I filled it with water. So make sure your plug's on tight, and we want to invert it a little bit to get that material loose in there. So it's all in suspension in the water. Now I'm going to hurriedly dump it in, and all the material's gone out, and the material is sitting in the silt fence, and the water should drain through, and all that's going to be left is our fine sand material. Some of the silt particles and clay particles may go through with the water, be a little bit discolored, but none of the larger pieces, erosion problems, will get into it itself.